sure about that? You sure about these independent?
Oh, there it goes. All right. So I'm going to talk about C# Metasploit payloads. Basically taking, using Metasploit MSF payload to generate x86 shellcode that's going to be run from managed code. And because you can use things like Mono on Linux, Mono comes pre-installed on like most modern Linux installations now, Ubuntu, Fedora, SUSE, things like that. All modern Windows have the .NET framework installed too. So you can run these executables that you compile with that are .NET executables on Linux or Windows with no issue. And so just a really, really high overview of what it does is I added support to MSF payload to generate C# buffers. Let's see. Oh, I need to, sorry. Sorry. So basically, you can use MSF payload, and then you specify, it's kind of hard to read, but you use the letter H instead of like, so C would generate a C buffer for a C shellcode. I think P does Python and things like that. So you use H. H was the only thing we could think of that was in C# that wasn't in all the other ones to denote that it's going to be a C# payload. And so it spits out a buffer like that, and all of those bytes right there are the x86 shellcode that you're going to want to do. So that's a Windows executable, or Windows x86 shellcode to execute calc.exe. And what I did was, I've got this C# program right here that basically I've defined. I go to so does anyone not know what C# is? They don't know what .NET is, managed code. So basically managed code is kind of like a Java bytecode. It runs in a virtual machine, which is the .NET framework or the Mono virtual machine. And so it's cross-platform. It's not reliant on the architecture that you're running it on. And so basically what I do here is I've got a program that it will check the OS version to see what OS you're running. So if it's Windows, I do all this stuff down here. There's this type that you have available to you have a lot of ways to interact with native code from C#. So at the very bottom of this class right here, I'm actually defining a bunch of methods that are that interface with native libraries. So see, I'm importing some functions from libc. So mprotect, postfix memoline, free. From kernel 32, I'm getting virtual alloc so that I can allocate memory that's going to be rewritable and executable. And then I declare these delegates, which are in C#. They're kind of like function pointers in C++, so you can dynamically assign them to functions that are going to be called again. And so you can specify the calling convention. So you'll see the Linux one, you're going to be calling the function pointer as cdecl. The Windows one is going to be standard call or WinAPI, WinAPI calling convention. And so basically what I'm going to do is I'm going to do this essentially the way you would do it in a C program. You allocate the memory, you fill the memory buffer with the shellcode, and then you execute the shellcode. And both of these ways, the Linux one is obviously more complicated. Windows is like 3 lines. That's the 3 lines right there. You allocate it and copy it over. But basically what you do is you have to figure out what operating system you're going to be running the shellcode on. That's how you get the environment.os version. I use the int pointer size to figure out if I'm on x86 or x64. So if it's an x86 machine, the int pointer size is 4. The int pointer size on x86 is 8. So if it's equal to 4, then it's x86. If not, then it's going to be an x64. So I have my payloads here. These are all x86 shellcode. It's native shellcode that's going to be run on it. I don't have a Windows virtual machine, so I'm not going to show you running on Windows. But I mean, the Windows one is super easy. You use virtual allocate to allocate a memory buffer the size of the payload. You can specify the modes. So at the very end, you see I've got an int pointer of OX40, which is read, write, execute page. It's a read-writable executable page. Right underneath it, I copy my payload into the memory buffer itself, and then I use the get delegate for function pointer method that's available in the system.interop services namespace to get a function pointer that I assigned to the delegate, which I declared at the very bottom, which I just showed you. And then I just call the method. And that basically takes it, it calls it as an unmanaged function pointer, and your shellcode gets run.
Can you go back to line 64 right at the end of the screen? I scrolled off.
That one? Yeah.
Can you go back to the end of it?
Oh yeah, so that's just comments. So basically,
okay.
So OX1000 is mem commit, that's the mem commit, and then page read write execute is the OX40. So if you keep going down, so basically I'm detecting what my architecture is, deciding which shellcode I'm going to run. All of this shellcode that I used was generated with MSF payload. So I do the same thing for Linux as you would in a C program. I use POSIX memline to allocate my page. I check to make sure that I'm actually allocating successfully. And then I do this mode right here, which is read, write, execute. You have to be careful with this on Linux for SE Linux and stuff. And I'm actually going to show you something to get around that. I didn't implement it, but I found a really neat way to get around allocating read-writable and executable memory on SE Linux. It doesn't work on PAX though. So basically, I use POSIX memline to get to allocate my memory. I use mprotect to change it to read, writable, and executable. I finally use, I copy my payload in there. I use the same Marshall.get delegate function pointer method that I use on the Windows one, and I call it. And if I run it, you'll see, oh, that sucks. Let's build it again. Oh, what the hell? This just worked. I just ran it. I don't know what that's doing. Let's try this. Basically, the command that I'm trying to, that the shellcode is running is who am I. So it should print out my username. Metasploit payload. Can't read it. Let's see. Why is that doing that? Well, usually this works. I have no idea why this is failing to work. It's because I'm doing a demo of it. Well, I wish I knew why it wasn't working. So I guess...
Give any comments at the bottom?
I don't really have any comments on the bottom. This is all on GitHub. There's no real, I mean, this is just the declarations for the methods that I'm going to be using for play on managed code. I wish it were running. I have no idea. I was just running it when I was over there. So I don't know why this isn't running. So let me open up with a caveat that I found with running it on SE Linux. There's actually a way, I don't have internet, so this is loading it out of the cache. There's this guy who, Drepper, something, his first name starts with a D, his last name's Drepper or something. He came up with this technique to, you basically create one file pointer, and then you map it twice. You map it first read, write, and then execute and read on the second one. And then you do it, so that way you're not having to do read, write, execute on one thing. So that's what SE Linux looks for, right? It's looking for if you're allocating memory that's read, writable, and executable, it's going to try and solve that. So he takes the same file pointer, and he makes a write one right here, which is read, write. He makes another one that's executable, read, and execute. It's the same file pointer, it's just mapping it twice. And then he writes this stuff using one file pointer and then executes it using the other file pointer. And he actually gets around executing shellcode on SE Linux by using this technique. And this is, you can Google Drepper SE Linux and this page will come up. I really, really wish my demo would work because it's really fucking awesome. But
does that error message down at the bottom mean anything?
No, so it says cannot open assembly because it's not a valid SIL. Let me try. I'm going to try rebuilding it, cleaning it and rebuilding it. Maybe for some reason it got fucked up. Yeah, there it goes. Okay, so that's my username. So the shellcode that's running is just Linux x86 exec who am I /user/bin who am I. And that was the x86, probably the 64-bit one. Yeah, so it's this one right here. And that's just shellcode that Metasploit generated for me. I uploaded this to VirusTotal, and only 4 of the VirusTotal people picked it up, and it wasn't. None of them picked it up for Metasploit. A lot of times, if you upload a Metasploit payload, it will say this is a Metasploit payload. They just understood that there was shellcode inside of it, so you could totally obfuscate the shellcode inside using like an encryption method or something like that, and then decrypt it right before you want to load it into memory. This is I don't have internet on this machine, but if you go to github.com/BrandonBerry with no E in the last name, it's in a gist that you can just download and play with and stuff like that. So that's any questions on running that kind of stuff? All right.